Hey, John. In a moment of psychic amazement, I looked straight at the line where it says Stop Chat. I was looking right here. I leaned back, I took a sip, and John appeared just as I was looking, and exactly there. Amazing. Even more amazing when you realise there's lag involved. How you doing, John? I'm good. Thank you. Continuing my quest for the perfect interpolated cube. Right back. I'm implementing my triangle strip, quad emulating cube triangle strip. How's that? Let me get that camera. Quad emulating cube triangle strip. I'm exhausted after saying that. Right, back, top left. And that'd be number 11. And then we have to get to 12, which is the same as back, bottom, right. And we get from there to 13, which is back, bottom, left. And the same one again. 14. I was only joking about the psychic thing, right? It's just humour. Because it's all gone very quiet now. It's like... uncomfortable silence. Right, so 14, 15, what's the 15? Back, top left. Back, top left, 16. Front, top left. That's number 16, front, top left, and then from 17 is back, bottom left, and then 18, front, bottom left. Also 19, and then I also need to do 20 here. Oh, 20. Maybe that's wrong. Back, bottom left.
back bottom left on there up to 1980. Really? 17? Oh. Yeah, this should be front. Back bottom left, front bottom left, front bottom left. And then we have to do 20, which is the same again. To 21. Back. Bottom left. Bottom left, that's 21. No. From bottom right. $21. 22. 23. 23. We'll do the same again for 24. Then we have to do 25, which is top, back, top, left. To 26, back, top, right. To 27, front, top, right. To 28, front, top, 27, front, top, left. Concentration. 28, 28, 28, 28, 28, 28. Front, top, right. That's the front, top, right. It's 28. Go to 29 is the same one again. Ching. And then 29 and then 30. No, it ends there. So this should still draw a cube. I have no idea if this will work. It's probably all going to be twisted up and everything. It's probably going to be a compile error. Syntax error, line 77. Okay, try again. I think, hey, hi there, Dan. How are you doing? I am building a perfectly interpolated cube. Though it's a bit far from perfect. Hi Mike, how you doing? I need to go through the thing. We'll start off with 0. There is now a level 0. Zero, 1, 2, 3, 4, 5, 6, 7, 0. Actually, for this, 0, 0, it's spinning around 0, 0. So this one is X, Y, and Z. So this is a front because the Z is negative and I've got increases distance away from the camera. Front, bottom because it's negative Y, and right because it's positive X. See, this goes to number 8, which is that, which is fine, and 9, which is the same. We have entered the twilight zone. The third dimension. Because 2 dimensions is just not enough. Interestingly, the universe has, as we understand it, has 3 dimensions, which is really handy because if it was 2-dimensional, then nothing would work. You wouldn't be able to have 2-dimensional machines or 2-dimensional things, because the problem is that if you had like a ring like this, there'd be no circle, there'd be no way of getting inside it without breaking. If you lived in a universe where things can't pass through each other, if you live in a universe where things can pass through each other, then I guess you can get away with just 2 dimensions. So maybe somewhere there is a 2-dimensional universe where things just can pass through each other. But since we live in a universe where things can't just pass through each other, they had to be 3-dimensional for aforementioned reason. Just kind of interesting. But then what's really weird is that, in fact, most of what we perceive as matter is actually empty space. Well, what happens if you sail out over the horizon? Well, matey, you cannot sail out over the horizon. It is impossible. For as you move nearer to the horizon moves further away. It's like trying to get the pot of gold at the end of the rainbow. move towards the rainbow, and the rainbow moves away. Then eventually it disappears. Got any more trick questions for me? I'm ready. Not so easily tricked. Or did I just fall for it? You saw this movie yesterday. Which movie? They said they lived on top of a mountain that was supported on the backs of yaks. And below the clouds was nothingness. Smallfoot. Ah. I think they borrowed maybe something from Terry Pratchett. Because everybody knows that the world is a disc. Held upon the backs of 4 giant elephants resting on top of the great turtle Atwin. We all know that this is the case. But the problem was, as it goes in one of the books, that there was a denial that the turtle was really there, you see. And there was this rebel group who believed in the turtle. And in fact, they were right, because there was a turtle. And their catchphrase was, "The turtle moves." I sometimes say that spontaneously and confuse people with it. The Smallfoot trailer, yeah, I get the idea. I mean, maybe depends what it's based on, but if it was sort of a new kind of story, then it was definitely inspired by. But then, having said that, I think that Pratchett's was inspired by something else. So it's some actual thing. If you want to know more about a turtle, the turtle, not the turtle, the turtle moves, check out the book Small Gods by Terry Pratchett, which is really good. It's one of my favourites of his. I played the guitar. So really I have 2 sides here, and those 2 sides seem all correct. Now we'll go and uncomment region and try again. And now I should have 3 sides. And say there is something wrong with this side. So that's starting with 10 to back, top, right. That's correct. Which should go to 11, which is back, top, left, which is correct. Which should go to 12, which is back, bottom, right. It flickers because it is overdrawing on another triangle, and it's drawing one on top of the other, and then they do have a habit of flickering, because it just depends on how they're drawn. And as the thing rotates, it sort of changes. It's called Z fighting. It's a very common thing. You see Z fighting, you know you're drawing 2 triangles on top of each other. The reason it's happening is because I've got a mistake here, clearly. This one should be 12 is back, bottom, right, back, bottom, right. And then we can also do back, and from flats to 13, which is back bottom left, and then back bottom left again. Now this doesn't work. And this is very distressing. 10. To 11. To 12. To 13. Why? It doesn't. 10, and I suppose the two are going for 20. What is that? It appears there's a rectangle in the middle. I don't get this. What's the rect? There's a vertex in the middle. Certainly the middle. And where did that come from? I don't have a middle vertex. Oh, this is terribly confusing. Maybe I'll just comment out these and then I can see comment reading. I'll do one more triangle. No, that's actually, I need to uncomment out this one. See? Right, so it'll be, this is the one. This is the culprit. This is the out of control triangle. One exceeding the bounds of acceptability. This makes no sense whatsoever. Everything was going so well. Oh no! Oh, you've seen it? Have you seen it? Oh, it's hilarious. It's so funny. Oh, can you spot it? It's spot the bug. Spot the bug time. We'll have that. I'll do a little musical interlude. I'll do spot the bug time. Spot the bug time. Dino has spotted the bug. Can you? Oh, it's a corker. You see it? Because it compiles, right? So it's confusing. Because you say, well, how can it compile? And how can I end up with? How could I end up with half a? Oh, you'll kick yourself. It's there, right in front of your nose. Do you see it? And then it's the question, as I said, is why didn't it generate a compiler error? And even that, and that's a really cute as to why. I don't think they've ever had it quite. I've had similar ones, but I don't recall getting exactly this one before. Two character vases, very 40-column screen. Yeah, but what do you want? You want, it's the same one every bloody time. What do you want me to do? Distance of the length of the site. Should we try that? Oh my gosh. Two character vase. You're ready to? Yes, it's rant time. Here, look. Because there are people who say you should never use two character whatevers, right? So, okay, so just for them, I can go and do, no, let's just do that. We'll just go, okay, size, and replace it with the length of each side of the cube. Yes, that's so much clearer. We can see so much more clearly now. The rain has gone. There are no obstacles in my way. Sorry. Have I made my point? I think so. We'll take that as Mike has, in fact, capitulated there on this one. Let's put it back. Look, seriously, can you see it? Look, can you see it? I'm pointing at it. It's just, look, it's right in front of your nose. Oh. I give clues. People are stuck. This is one that you can spot even if you're not a programmer. You just have to be very observant. Boom, boom. Hey, refly. You're back. Goodbye. So, maybe refly can see it. Can you see the bug? Look, the problem is that the cube, look, I'm trying to build the cube. I added the side, and the side's the one that's flickering. And it mysteriously, right, it's half the length of a side. Which is like, where does that come from? Because when you look at it, you can see that everything is the same size of the vertex everywhere. And so where did that come from? And I was looking at it and going, what? And then I saw it. It's one of those lovely ones that's difficult to see. So now I thought I'd turn it into a game. Who will be the first person to see the bug? I mean, other than me. I've got all day. If I don't get it right, does that mean I'll get less free drinks at Mike's bachelor's party? Yeah, when is this party going to be? We all need to know. There are the correct number of verts there to add one more triangle. Well, at least you'd think so. So the clue is there is something missing. But what? We all want to know when We all want to know when the big day is for Mike, so we can all look forward to a party where we get as drunk as can be. We're all waiting for the time when he tells us without a lie when it will be. That was pretty embarrassing. It's difficult to improvise songs and it not come out really crass. It's difficult to improvise in a song. That's usually a trick, is when I get stuck improvising. I start improvising about improvising a song. Anyone seen it yet? No, no, you're going to kick yourselves. You really are going to kick yourselves when you see it. No, that is not the correct answer, Mike. There is something missing. Can you see it? It's right in front of your nose. La, la, la. I do like this one. I'm just curious as well how much it takes. How much it takes to see these types of things. Oh, Mike! Oh, where? Where is the comma missing? You quite fully. No, that'll do. Yes, there be a missing comma. Do you see it? And then, what's really hilarious about the missing comma is that the missing comma did not create. Yeah, it's okay. I know. I was joking about which one. I mean, so it doesn't take a lot to plan it when you know it's a missing comma. You look for the missing comma, and then there it is. But the really funny thing about it is that the missing comma doesn't generate a compile error, because the following one is a minus a z. So what happens is, because C just runs from one line to the next, is this becomes sz minus sz, which is 0, and 0, that's why this becomes 0, so this explains why you get, but no compile error. If this wasn't minus 0, then you get, yeah, if it wasn't a minus, you get compile error, because then you end up with two numbers next to each other. So it's a cute one, that. It is. Lovely. Yeah, it's a bit of a classic. It's a classic. Anyway, there we are. The prize goes to Mike. He's still got to invite us to his wedding do. Because it doesn't matter, Mike, how many times you say it isn't happening. We all believe it is happening now, so that's the problem. You know, this fake news thing, you know, once it starts, there's nothing really you can do, you know. softly, it's the chords of softly inhaling sunrise. Why? What was that? She's the boss. Oh, well, that's not marriage then, because it's supposed to be, you know, going together. You know, it's like a partnership, and so yeah, you're excused then. It must be my lack of nutrition. I'm making sure. Yeah. Yeah, I think it's on the sound of it, we might have to sort of bring our own food as a backup, I suppose. I don't know. Anyway, I would like to, yes, as you can see, it worked. So what I'll do now is just try putting the rest of these in. And then we'll see what we get. Uncommon region. Yeah, so that looks like something like a cube. Now, the whole point of this is that each face of the cube is now constructed using 5 vertices. The 5 vertices mean that the geometry shader should be able to pick out each of the vertices on the set. So, where's the picture? We go, where'll be the picture? There'll be the picture. So, I'm going to try and see if I can do this. Oh, right, okay, I need to set the color, though. This is true. So the colors is going to be sort of a different thing here. So let me try if 0, and we can do hash end if, and if we do the hash end if here, and I need to set, do I need UVs? I will, but I'll come to those. The colors can now be a little more manageably organized than before. You can see it's been a mess. Using a macro to replicate. Famous salmon. In fact, how are they famous? I only talked about. Is that enough? I just sort of mentioned something and it's famous. If that's the case, then I can offer a new service. It's like if you want to be famous, all you need to do is send me an amount of money that's something that we can negotiate, and then I will talk about you, and then you will immediately become famous because it worked for my salmon dishes apparently. So, come on, I'm gullible. I just believe everything everybody says. You see, you're gullible. Bye. Okay, so what are we doing? Colors, and yeah, colors. They should follow the same pattern in order, right? And so we'll start off with red. Yes, we'll start off with red. And that's for 0. No, that's not red, that's black. This is red, right. And the next one we do is go to 1, which would be green. This would be 1. 1, 1. And then we get to 2, which is yellow. 2, and then we go to 3, which is 3. Right, that's blue. 3, blue. And 4 is, well, nobody cares. And then we go to 5, which is going to be, okay, red, green, green, because it's on the same corner as the 1. So I do have to line those up. And so this will be number 5. And then goes to 6, which will be what colour? It doesn't matter, but it can't be red or blue, because I already have them on this. This is going to be red, this is going to be green, sorry. This is red, this is green. So we could go yellow, I guess. I did already do a blue though, which was 3. But because this one is blue, this cannot be blue. So this has to be yellow. Six, and from there we can go to 7, which we already know is blue. And then we can go to 8. Which has to be red. And then 9 is the dummy one to get the degenerate triangle. And then from 9 we can go to 10. Where are you? 10 is up there. And we already know that 10, this one has to be yellow. And then from there we go to 11. Well, if we know that this is red, green, yellow, 11 has to be blue. And we go to 12. And 12 is red. And then 13 what's 13? I can just use a simple little trick. The same colour always has to be on opposite sides, because of the way it works out. So I know this one has to be green. And go to 14 is another degenerate triangle. So yes, I do have to put these degenerate triangles in, but I am genuinely lighting up each vertex in the mesh, in the strip. So this is pretty much as good as you're going to get. If I can get this to work. 13, 14 has been done. We go to 15. 15 is opposite of blue. So it's blue. And there we go. 14, 15. And we can go to 16, which is red. And 16, we go to 17, which is green. Then we can go to 18, which is yellow. Yellow. And 19 is the degenerate triangle. 19, and we get to 20. Number 20. At number 20, we have. Yeah, that's one of those things from the past. It used to be radio shows that would do the top 20, and they'd play the top 20 songs in the charts. We used to listen to those all the time. I don't know if those such things exist anymore. I suppose there must be music charts. Top of the Pops. I know. That was the TV show. Yeah. Top of the Pops. People don't like to talk about Top of the Pops much anymore, because one of the presenters, on the most famous presenter of Top of the Pops, was none other than Mr. Jimmy Savile. Mr. X Knight, well, he's an ex-person as well because he's passed away, but that's kind of, yeah. So it's kind of difficult for the memory of Top of the Pops to really recover. But it was, yeah, interesting. The whole thing was very weird. I find it particularly weird that all the things only came to light after he died. He must have. There must be some story behind that. Terrible. 21. So 21 is blue. "22 is green. "23 is red. And 24. Okay, and now we've just got one more to do, which is 24. We need to get to 25. Which is 25 is green. "26 is red. "27 is also red. No. How did I say 26 is red? It cannot be red, it must be yellow. And this goes to 27, which is 28, which is yellow. And then 29 is the degenerate triangle. So that should be the colours sorted out. The reason why it's all wrong is because I'm still using the old system Rooney. Okay, well, I need to look at the shaders now. I'll be right back. So I'm looking at the shader here. When I get the colours, they're going to come in through here in the vertex shader. Now, looking at, sorry, I'm in here. I need to see what am I passing in. I'm not going to pass in MISC anymore. I shouldn't need that anymore because I'm just going to use, or try to use, the colours that, it's probably all black now. Right, I'm going to try to use the just normal colours. So that's in colour. Colour equal a colour. That's done. This passes through to the geometry shader. The geometry shader shades 3 triangles. So we're going to try this only with, I think I should try this first of all, with just one face. Comment region. I should just have one face now. There it is. Just keep it simple. The face, the geometry shader, I should get, well, I get a triangle strip. No, it's triangles in. Now, let's have a look at the tutorial thingy. Yeah, so it's the triangles. That's all I need. I'm getting the triangles in, and out comes a triangle strip. What's weird about this is that despite this, Oh, I don't know if this is going to work, because one of the things that's a bit weird is how it manages to draw everything, even though I didn't have the geometry shader emit vertices for everything. Oh no. You see, what's worrying me is that I was expecting the GL in to be the position of all the vertices. Because it's passing through, but I'm not having to tell it to pass through the other ones. No, I've got a bad feeling about this. Line strips with adjacency. I'm beginning to think what I need is a triangle. Oh my God, there's no end to this. I need a triangle list with adjacency, which is only available in OpenGL 4.4. Ah, so it is only with GL 4.4 that you can actually do what I'm trying to do then. And that I've made the mistake of thinking that all of the vertices would be available. They're not. The geometry shader still works on one triangle by triangle basis. So my plan doesn't work. I mean, I could. Yes, it might be that I will have to use Vulkan. Oh, it's not going to work. Oh, flipping heck. I'm going to use a different technique entirely, which is adjacency. The problem is that I need to know. I don't know. See, I thought, yeah, if it makes sense, I thought that if you used, you know, a triangle list, the geometry shader would get access to the whole thing, but of course doesn't. The array is used to deliver the 3 vertices. So what you basically have is the vertex shader can only see 1 vertex. The geometry shader can see the 3 vertices of every triangle. I need to see 4. No, because there's no state possible. It's not possible to hold any state anywhere. There's no real solution to the problem. I'm back to where I started. I'm a little bit further. What I can learn to do with the geometry shader is that I can mess with the colours on the basis. I could come up with an algorithm. It's kind of useful to know. I can come up with an algorithm that takes the colours of the 3 vertices and does some combination of the 3 and sends that output back. So I can map colours with the geometry shader. So that's good to know. That's what I was going to try to use. But the problem is that I still can't see beyond now. So here we go again. So I almost got there, but once again I have been foiled. What I have to do then is go even further then, which I'm going to have to go to a newer version of OpenGL. Oh God. where I have to use this GL triangle's adjacency, which now promises to be what I can solve this problem with. Ay, ay, ay. But, you know, it's great because this problem is taking me on a tour of virtually all of the features of OpenGL, so it's a really good problem to solve. What am I going to do? What I'm going to do is, now, just having sorted all of this out, I am going, which was no doubt will come in handy one day, I'm going to use indices, but the problem is well, I don't know. Can I use, that's the question. Triangle adjacency contains adjacency data for triangles. That's a statement by somebody who's been reading the OpenGL specification very carefully because it's full of that kind of stuff. So that adjacency triangles can be accessed. The geometry shader stage has access to 6 vertices and attributes, which forms 4 triangles. 3 vertices form the triangle currently rendered. The other 3 vertices are forming the neighbouring. If a geometry shader should pass the rendered triangle to the next stage, only has to process 3 points only, which form the triangle. Everything is saying, okay, so it's time now to redo my cube. It's never ending. Using vertices. Because this was making a cube with a strip. it's terrible. Zero, 0, 1, 1, 2, 3. Wait a minute. Oh my gosh, then I have to set up the EBO as well. Oh, oh dear, oh dear, oh dear. Now I suppose I'm learning. Let's do it. 0, 1, 2, 3. Let's just number these first of all. 4, 5, 6. Unity can't do this. Must be joking. There's no way it could do it. I'm trying to do this very specialist thing. I'm trying to draw rectangles. They're very specialist, apparently. Yeah, yeah, people mess with me all the time. That's why I'm such a mess. Okay, we're going down the route of the cube. We're going to go with adjacency, and I'm going to have to jump up to version 4.4 of OpenGL just for my thing. Top, front, top, left, 0. Front, top, right, 1. Front, bottom, left, 2. Front, bottom, right, 3. And I'm going to change my mind here. 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. I'm going to use this order. I know, but I don't care. Remember, I'm here to put the fun back into whatever. I do have a solution that works with other hardware, but it's messy. Remember, I did manage to achieve my cube, but it required having 4 colours per vertex. I was trying to avoid that. The reason that's a problem is that it means a lot more work if I'm trying to animate them. 4, 5, 6, 7. So there we have our 8th thing on there, and then I want to put the indexes. And it's true, I really should support indices. My engine doesn't really support indices at this time. So and so let's just write the indices out. 0, 1, 2, probably going to get them the wrong way around. 2, 1, 3, 3, 1, 5. But where do I put the adjacency information? That's the bit I don't get. See, the reason for the adjacency is like tessellation or something, because I'm using it for a different purpose. Triangle strip with adjacency. Naught, 1, 2, 3, 4, 5, 6. Ah. This section needs to be filled in. Yeah, great, good job. I can't fit an example. It's this one again and again. I keep coming up with this one. It's just not clear to me exactly how I'm supposed to index it. Well, the easiest is triangles adjacency. I can also do triangle strip adjacency. One. So maybe the easiest way is to construct it using triangles, GL triangles adjacency. And I don't know which, well, we'll see. Because this one, it's a mess. There really isn't much to be saved by doing it. So I'm going to go and get GL. I have to use this as my reference. So if we do this, that's it. I can put that down there and put this up here, and then I think I've got everything I need to try and create the correct indices. I'm going to build them out of triangles. So, oh, frack, this is 1, 3, 5. One. The first index is 2. I'm doing the front face. The next index is 3. No, the next index is the adjacent index, which I'm just going to make 2 again because it's not real. 2, 2. I don't use it. 3 would be 3. 1, 2, 3. 4 is the one I'm really interested in, and that is 1. 5 is 0, and 6 is also 0. So this becomes the first face using 6 indices so that I get the adjacent ones. And 2 of the adjacent ones I don't care about. How can I represent this? I said 2, 2, 3, 1, 0, 0. So it's actually 2, 3, 0, 2, 3, 0. And the one that I'm interested is 0.1 to get the, yeah. Okay, so the next, that's the first half of the face. Right. So that's the first half of the face. The second half oh, I see, it goes round in a circle. 1, 2, 3, 4, 5, 6. Well, then given that, it's fairly easy to do. If I know it goes round in a circle in an anti-clockwise direction, let's start again. Circle, anti-clockwise direction. Let's start with 0. The next one is 0 because I don't care. The next one is 2. The next one is 3. 3 because this is the adjacent, and I think I'll just mark the adjacent out like that. 3. And then so 0 to 0 to 2 to 3 to 1 to 1 and back to 0. Just like that. Okay, so the second triangle is 1, 2, 3. So it goes 1, 1, 2, no, it doesn't work that way. Start again. 0, and then I go to 0, then I go to 2, then I go to 3, then I go to 1, and then I go to 1. The second one is 2, then I go to 3, no, 2, and then I go to 2, then I go to 3, and then I go to 3, and then I go to 1, then I go to 0. Oh, flipping heck. That should create, that should be going 0 to no adjacency, so I say 0 again, to 2, to a 3 adjacent, to a 1, and then there's no adjacent, so I say 1 again. The second one is 2, no adjacents, so 2 again, 3, no adjacents, so 3 again, 1, and the adjacent is the 0, so this is this triangle with this adjacent. Jeez, this is a mind. It's really good for me though. Pretty good exercises. The next one then, we'll carry on with the same pattern, is 1, 1, 3, 3, 7, 5. And then the next one is 1, 3, 7, 7, 5, 5. That's a nice pattern. Next one, 5, 5, 7, 7, 6, 4. I'm doing my best. This is running and running, I know, but you put the pressure on. 5, 7, 6. The next one is 5. I already did 5, 7. No. 5, 6, 4 with a 7. So this one is 5, 7, 6, 6, 4, 4. So that's half the cube done. Next one. 4, 4, 0, 2, 6, 6. Next one. And it's the wrong way around. Going anti-clockwise. 0, 0, 4, 4, 6, 2. Next one. 0, 4, 6, 6, 2, 2. I've got just 2 more to do, is the top and the bottom ones. 0, 0, 1, 5, 4, 4. And 1, 1, 5, 5, 4, 0. And 2, 2, 2, 6, 6, 7, 3. And 6, 6, 7, 7, 3, 2. By doing this, I should have adjacency information, so the geometry shader can finally see all 4 vertices of the quad. It's insane. But it won't render it yet. Why? Because I am not supporting those lists yet. Light, platform, OpenGL, draw.c. No. That was a mesh.h. Get the right one. This is mesh type try adjacency, which I'm going to do as type number 2. It's a little crude what I'm doing. So this gives me this one, which I can do mesh type try adjacency, where we go here, and we need to draw, I think that might, well, yeah, that. Oh, come on, where was it that I saw that? There it is. Triangle. Triangles adjacency. Oh my God. Will you copy? Will you paste? Thank you. This GL triangles adjacency. Now, that's fine, but I still need to add the okay, that's in mesh. Mesh. Set colors. Set indices. Num indices equal num. No, I get that. Nummy. It's very nice and nummy. Yes, number of indices. And okay. And then what do? I need to save that, and then I go to draw, where I need to do the EBO. Yeah, that should be it in theory. Well, let's try and see. What's your hell making loose? Well, we had a compiler breaking loose. Mesh.c line 36 is not complying because I already wrote that function. What can I make of this? We
we see some interesting things going on. It's like a triangle strip, isn't it? It's because I did not change the way it was meant to be drawn. If I look at draw and I peer deep into the soul of the guideline, there was this thing. I created functions whose purpose it was to say what kind of a mesh. It is a critical mesh. Light mesh triangles. We do light mesh is triangle adjacency. Light mesh is triangle adjacency. This function needs to be in platform.h. This function needs to be called when I set up the mesh, which I think I did. Yes, I said is triangle strip now. Unleash the power of triangle adjacency. And yes, we have the famous and all too annoying nothingness. But to be fair, this might be because I didn't set the indices, because there isn't a function to set the indices yet available. Now there is. So what I need to do is set the indices. And we set the indices by. Hello, Tony. I looked at the screen then just before you showed up. First person on the chat tonight was John. He said hello. And you could tell that, you know, I was minding my business and I went up and I leaned back and I looked at the thing, and just as I did, he appeared. You could see on the screen. And so I made a joke about psychic thing. And I think he disappeared. I think I scared him off. Just, are you still there, John? Did I scare you off? But I just did the same with you, Tony. I looked. I was like, boop, boop. Amazing. How are you doing? How are you doing? Mesh type triangle adjacency. And I need to set it. That was it in. No. Oh, come on. I've kind of lost track now. I was in main, wasn't I? I want to do light mesh set indices to call the mesh using the indices. Oh yeah, I called it indices. Indicile. And
What? I need to know. I need to know how many indices. Well, I can do size of indices. Any ETA? I don't know. I came this close to solving the problem again. And then I found out that in fact, you can't do what I was trying to do using geometry shaders, which is access the fourth whatever, but it turns out that in fact you can if you use a different kind of primitive known as an adjacency, in which you define your mesh. You define your mesh to have more vertices. In fact, each triangle, instead of having 3 vertices, has 6 vertices. This way, every edge, you can get access to adjacent indices, adjacent vertices. Now, this is normally used for things like tessellation. You go and say, I want to split this up. If I want to split this up, then I need to know what the adjacent thing is. But little did they know that by adding this feature for this particular purpose that they're interested in, they open the door to the possibility of me recreating, yes, quads. Yes. Foiled on their own petards. Yes. I'm not saying there's a conspiracy to banish quads, but divided by size of int. What do I get then? I've set the indices, and once again, the most famous of results, the blank screen. What does that create? Yes, the blank screen. Because there isn't really much you can do, you know, with a blank screen. Beep, beep, beep. What I'm going to do is comment out the region so that I only have one triangle. If I can get one triangle, no. I set the indices, size of indices divided by size of int. There it is it that I'm missing. I'm missing something. The vertices. Can it be the vertices? Where be the vertices? Where are they? The indices. See here, it does copy the indices, which you bind the element buffer to the VAO. Really?
Yes.
We copied the verts over. Yeah, I mean, you know, there's this. It is GL buffer data. Enable. Oh, you need to be a little bit more, shall we say, draw arrays.
No.
One does not just draw arrays. One must draw elements. Because this needs to be. That didn't quite work out the way I wanted it to. Doop, doop. Wrong button. Doop, 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 doop. But why? It needs to be the number. Draw, mesh, nummy. Do I need to bind the... I don't know if I need to bind the EBO, if I need to bind the index. We'll have to see. Have to see the index, bind, open GL, bind, indices. I mean, I don't think you do need to bind it. We'll try it. Here it goes again. I still have blankness. Bind vertex array. Let's just check a web search on bind vertex array. Draw arrays. No, I don't want to draw arrays. I want to draw elements. Open GL indices example. Okay. Element array buffer. Is that what I called it? Element array buffer. Yes. And I copy into the element array buffer. Yeah. Bind buffer. Oh, yes, you must bind it. Of course. You can't just use any old thing without finding it. What is this? Bureaucracy-free zone or something? GL element main buffer. Main buffer. Element buffer. No, not element buffer. Element buffer, that would be too. Let's draw EBO. Draw EBO. E-I-E-I-O. Oh, no, it's still not working. It's just like some guess the bit that's missing, you know. I'll go and have a look at the example. Here it is. We bind the buffer and then we draw elements. We bind the buffer. Then we draw elements. After having had it all copied over, mesh triangle adjacent GL, draw elements to the adjacency. Well, one of the things I could try is it might be that the adjacency is not working because I'm on the wrong version of OpenGL. Come on, let's get something on the screen. Oh, this is frustrating. I am loving it. I'm loving it. I'm loving it. And it hates me back. Yes, that's what's going on here. Oh. I'm going to pretend it's a triangle strip. If I pretend it's a triangle strip, then I get stuff happening. That was a little bit disconcerting because I thought I got rid of the vertices. I only have one. Ah, no, it's because of vertices. Ah, you have returned, said Refly. Refly, I have returned, Refly. Your return. If there isn't a spinning cube containing all the colours the human brain can be interpreted, you will tell me your 3 favourite Italian stew dishes. Coniglio. They're not really big on stews. The only Italian stew dish I can think of is rabbit. Yeah. So I know you say I have to, but I can't. I mean, if I can't and I have to, that's just like the immovable object meeting the irresistible force, but sort of the other way around. And or on the other hand, I say, your paradox. Bye. I don't know. I mean, look, it's drawing it, right? They're drawing something, as long as I pretend it's a triangle strip. If I don't pretend it's a triangle strip, well, you know, I've set the indices. So I suppose one other thing I could try is, well, I am doing it, I'm drawing triangles, right? Oh, you're not a stew man either, that's why you asked. It's beginning to sound like one of those sort of like spy code greetings. Winter is around the corner, and I want to try cooking some stew dishes. Now, what's really freaky about that is that I started saying that about the spy thing before reflight. Do you see that? Winter is around the corner, and I want to try cooking some stew dishes. I'm not a stew man either. That's why I asked. Do you have any soft-shelled crabs? Yes, in the basement. Hey, Tony, that's a good question. Did I ever get a troll? On YouTube. Is that one now? Did you ever get any troll on YouTube since you returned streaming? Resumed streaming? I'm sorry, you fumbled that. Prepare to die. Oh, sorry. Stop. You're getting too silly. You are trolls? Then, Mike, why ask a question that you already know the answer to? Yeah, get out of that. Yeah? Get out of that. It might be. I mean, for all you know, the actual real purpose of my stream here could be to communicate secret messages to to a very secretive underground movement who believe the turtle moves. It could be. Not that likely. Tony, why would I create fake accounts to troll myself? I mean, what do you think I was doing on the broadcast? So there, when I was doing here on Twitch, it's like, yes, the night before I prepared a whole scripted thing with a bot and all that to log into the channel and, you know, type these messages out. And I would rehearse it and then have this yeah. What's it? Self sock puppeting. Becomes like Punch and Judy. Oh yes, he did. Oh no, he didn't. Oh yes. I don't think we should go there, Tony. Okay, look, I'm trying my best here. What I'm going to do is just comment this out, in, out, shake it all about. It's like, yeah, I think that's been mentioned before. What's gone wrong? I got through 2 indices. What's wrong? Well, undeclared. What do you mean? I was only going 65. So there is a stray. What, the L? There was a stray L. Oh. Look, I put 3 indices in. It's the simplest thing in the world. 3 indices. There they are. They're the vertices. Here are the indices. And then I go here and I go set indices. And there we are. And then this is it. That's the size of the indices. There's the number. Or is it? What does that do? That function. Let's take, maybe because I'm not doing the function right. If I go back to draw, I'm over here, and I'm saying draw the triangles from the nummy of the thingy and the draw EBO of the EBO that's set. I mean, you know, I'm trying to draw a triangle here and I have to jump through friggin' hoops. My verse and above are going to work. EBO. What happened to it? There. And there we are. And we copy the indices. So now I need to check. When I copy the GL data, let's have a look at this function, and it probably takes the number of bytes, and GL buffer data takes the size, where the size is the size in bytes, which is of course why it didn't work. Times size of int. Oh dear me. There's always some complication. And then I try again. Is this the reason why I had nothing? Do I give me something? No, too few arguments to call. Let's compile error. Draw 112. 112. It just goes on and on and on and on and on. I did the wrong thing because it's not here. I did the wrong place because I'm not paying attention to what I'm doing. I put it there instead. And then I try again. Yes, yes. For I have a triangle. My triangle is spinning a bit like a paper plane. We have to watch the vertex buffers really carefully. I'll take that as progress. Next. If I remove these and put back this, and then say you'll always remember your first triangle. It's true, Mike, it's true. I remember my first pixel. It was a proud moment. There I was, me and my pixel. What's the weather like where you are? The weather here is very, very, very wet. It looks like it's something like 120% humidity. That's what it looks like. Very, very wet. I imagine that I had an idea for a game because I went to get my pizza, and I'm talking about bucketing it down. It was bucket, so there was a little kind of gap. And I went over to the pizza face because I had things to do. I couldn't. In the end, it was late. I'm getting a pizza. I went over to pizza face, got a pizza. Not very far from here, and but it was really cold. So I just waited for it in the shop, and there it came, and it's like the rain. He'd been bucketing down, and there was a little sort of lull. And so then I'm going for it. And so there I was with my pizza running down the street, and the rain is coming down, and my pizza box is getting wet. And then I get in, and it was all fine. But it made me think of a game, which was like, I mean, the name and everything. It's like with the design of it, and it's Noah's Pizza Delivery. And basically, is you have to deliver pizzas in the rain. Heck, it could be really funny. You've got a pizza box, and if it gets too wet, then it starts disintegrating. And you have to go to knock on the door, and here's the pizza. You know, it's like that's it. It's kind of like because you know these sort of something is very popular these days, because you've got to look at what kind of themes would make for a successful game. Because the theme, the narrative is important and all that. So let's have a look at the situation. If we were coming up to the apocalypse, there's probably going to be a kind of interim period where there is still pizza delivery. We could probably say that society, we could say that the point where you're pretty sure that society has gone pear-shaped beyond the point of recovery is when pizza delivery is no longer a thing. I put this forward as being the kind of the point that it is. But you can imagine that as you're getting closer and closer to this point, there will still be pizza delivery. And it could be interesting to look at, the final stages of the existence of pizza delivery, as the weather gets more and more kind of crazy. And yeah, there we are. What do you think, weather? It's really quite entertained. It's crying with laughter right now. Yeah. Yeah. Rain in KOR first. Oh dear. Maybe, I don't know. It's such a long road. Look how long it's taking me to get a cube. Well, I mean, not just any cube, a very specific kind of cube. Anyway, random hard-blowing wind, absolutely. You could have sort of like risk mitigation. If you know that the customer that you're delivering to is a particularly important person, then you can decide to order 2 pizzas. So just in case, because then the top one is getting wet, but at least the one underneath will be still okay. Dodge cars, yeah. See, it'll be fun. Noah's Pizza Delivery. We deliver pizzas to the end of the world. Right, so it's that. So what was I doing? Oh, I needed to change something here, which was meanwhile Noah. You've heard of Noah's Ark, right? There you go, Noah's Pizza Delivery. Just with the theme of the rain and the end of the world and the climate change. Pizza delivery meets climate change. I think it's got something to it. It's like, to the end of the world. Every stage different. Exactly. Yeah, you got it. Yeah, this has got to be done. This is just such a cool idea. Yeah, because it doesn't have to just be floods. So we can have, because the thing is that there will always be rich people, even in the final stages. There will always be people there who can, be. So you can have that whole situation. There could be all different things. Zombie apocalypse. The one where, in fact, there are no cars anymore because there's no fuel anymore, so you have to cycle. Yeah, I am kind of thinking of something a bit like inspired by Paperboy. Yeah. It's a different kind of apocalypse. That's it. Because you're it's not going. I mean, just in the same way as you can't. It's not a video game if it doesn't have a bloom and lens flare. You can say that no apocalypse is complete without pizza delivery. So it's a natural. I'm wondering whether people, are going to. There should be, if it hasn't already been done, there should be a thing where people take retro video games, classic games, and remake them exactly the same as they were, as close as you can get it, but with the addition of two things: lens flare and bloom. And that's a whole genre be a whole genre in itself, wouldn't it? It's it. So you can have Paperboy with lens flare. It's going to be interesting because the view's down like this. So how are you going to get lens? You just put the lens flare in anyway. Yeah. So. Oh, well, okay. The screen. Okay. And I have screen shake as well. Okay, but if we're going to do that, where does it end? We can have grey. There was a period a few years ago when every single AAA game that was coming out was all grey. There was a fashion. It was grey. It's like, here's a first-person shooter. It's just the same as every other first-person shooter you've ever seen, but this one's grey. I'm glad we snapped out of that now because this whole colour has come back, into fashion. It's like, it's terrible. Orange, blue and orange face. Oh dear. Huh. I used to put sarky replies to those. I used to say, but it's so grey. It's just, I should not get me started, really. And as you guys didn't start it, I started it. Of course I did. So what was I going to do? I was going to change the triangles to something else. GL triangles. You can tell the people who are designing OpenGL, they really, really like long names, you see. Like, because it could be GL tri. It's triangles. Adjacency. Yeah, that doesn't work. Oh, because it said adjacency. Wait a minute. Yeah, no, that's correct. One of the problems then is you have to. It just disappeared. When I set to use adjacency, it disappeared, which is sad. I should put something on the screen. Oh, well, there's no errors. Yeah, but I'm shader. Yeah, but this is the thing. I'm just trying to use a more recent version. This is just going to throw an error. I mean, it's inevitable. It'll throw an error. No, it didn't. It didn't throw an error, but it didn't work either. Oh, but I'm using a vertex shader. Sorry, a geometry shader. Let's take out the geometry shader in case. Shaders line 51. No, shaders undeclared identifier 50. Yeah, 51 shaders. Shader source geometry shader 1 shader compiled shader. Okay, well, let's not bother linking it. That won't work. Oh, come on. No, I took out the geometry shader and it still didn't work. So why doesn't it work? This is the question. I know I'm saying triangles adjacency. That's very difficult. This is infuriating. Let's have a look at the GL draw elements. Count specifies the number of elements to be rendered. Wow. What is it? Because when we look at this, we see that draw elements. What has it got? Well, that's interesting, don't you think? Because it's adjacent, nummy, unsigned int, and null. Specifies a pointer to the location where the indices are stored. Why does it need to do that? Adjacency is available for 3, 2 or greater, so that's fine. I didn't think you needed to specify it. Are you serious? Let me check this, because this is a bit confusing, I have to say. It is, well, very confusing. The fourth argument in GL draw elements is what? I think this needs to be 0. And I wonder why. Why does it not work? If I go and do GL triangles, instead something appears on the screen. And I get text call def not declared as an output from the previous stage. So just to keep things going, I'll put back the geometry shader because that's the way it's all been set up. And then we have 2 triangles which are spinning, but that is because I have 2 triangles, you see. There we go, because I specified 6 indices. The problem is I should be, hi Dan, how are you doing? I should have triangle adjacency when I'm drawing. Oh dear, oh dear, oh dear. I did blank, so I can't. This is so infuriating. If I'm using GL triangles adjacency, I need to specify 6 vertices to draw 1 triangle. I have specified 6 vertices to draw 1 triangle. I've shown that's the case. GL, draw elements, GL, triangles, adjacency, not working. Just like, you see how long it takes every single step. Not displaying. The GL triangles adjacency does not work. I'm out of ideas. I don't know what to do. It's got down to the point where if I use triangles of adjacency, it don't show up. Oh, I see. I don't see. I'm stuck. I can't proceed any further because I don't know what else to try. I mean, why would saying triangles adjacency not work? Here we are. We're doing triangles adjacency on. Where are the indices? Here. I should get something on the screen. Nothing. How do I find out why it doesn't work? You got weird shapes. It's better than getting nothing. Oh God, you guys are so sensitive. Here we go. That's the bottle tops. I really don't know. Anyone got any ideas? It's like I studied the adjacency, triangles adjacency. There's not very great, wonderful information on it. Most of the sites are common with what you generally see. Most of the sites that provide information, they've just sort of copied it more or less from other sites. So if there's a gap, it doesn't get filled. What are you supposed to do? It's like GL triangles adjacency. Showing results for GL underscore triangles. It removed one of the underscores. Damn you all. It's all right. GL multi-draw arrays. Microsoft pays you to promote DirectX 12. Not anymore, they don't. Not since you let the cat out of the bag, Refly. Be careful what you wish for. It's like, this is so frustrating.
There is some truths about internet forums. There is always one person who has as their avatar Darth Vader. Always.
Yeah, I don't know. It would take me take me ages to figure that out, I think. At this point, I know how to do it. I know how to do it. It's totally doable at this point. I have a solution, but I just can't get GL triangles adjacency to appear or do anything. I don't know why. Just nothing. All right, I need to check an example of I can't even find a clear example. can't find an example. You'd think the documentation, all these people involved in creating the OpenGL standard, you'd think they would have the time to actually sort of create examples. When you go to the documentation, it's devoid of them. Can't. Oh, this is so crazy. Let's just check something, and it's like, oh, flipping heck. It doesn't. This section needs to be filled in. These are special primitives that are expected to be used specifically with geometry shaders. These primitives give the geometry shader more vertices to work with. Their input, yes. Yeah, if you use GS with the GL triangle, so each execution of the GS will only see 3 vertices of the particular triangle. Yes, I know. These special primitive modes allow GS to access vertex data for adjacent triangles. Yes, well done. Here we are. This is on the Kronos group. This is the people who work on OpenGL. We're still waiting for them to fill in the adjacency primitives. To do. This section needs to be filled in. Yeah. You took away my quads. You removed my quads. You consigned them to the rubbish bin of graphics technology. You took them away from me, and I'm trying to bring them back because I want them. And what have you got? You've got me chasing a flipping thing and getting this close to it, and I have to use every ounce of that technology in your pipeline to recreate something that was originally already there. And for years, this has been to do. Tries of the future. You mark my words. The future is polygonless. Provoking vertex. Provoking vertex. One of the vertices in an output primitive is designated the provoking vertex. This vertex has special meanings for the primitive. For example, when using flat shading on output variables, only outputs from the provoking vertex are used. Oh, that does answer a question I've been wondering about. Every fragment generated by that primitive gets its input from the output of the provoking vertex. Each primitive type determines which index in the vertex stream defines the provoking vertex for a particular output primitive. There is a way to change the provoking vertex convention, primarily for direct 3D compatibility. Way to go. create the page GL triangles adjacency. It's nearly 1 in the morning. I'm stuck. Let's check the documentation for draw elements. Specifies what kinds of primitives to render. GL triangles adjacency. That's accepted. There are errors. Oh, well, how do I check the errors? How do I check the error? Okay. OpenGL, check errors. Okay. Let's do this. Oh, there we go. How to check errors. To do. Check which to-dos we still have to do. What is the type? How do I... Oh, returns an error code. Let's see. There must be an error. There is no error. There are no errors. You think I would help you by giving you a clue as to why it doesn't work? Wait. I was speaking too soon. You have fallen into my trap, Dino. You are suffering from error 1282. Because yes, we know. We need a lot of errors. Let's see. Okay, you've been caught out again. Why? Did you really think it would be in decimal? No, I didn't actually. But yes, you just didn't think. Come on. I needed to flush the buffer. I can't board waiting. Flush the buffer. Oh, there he goes. It is error 502. Ha ha ha. The juicy one. Given when the set or state of for a command is not legal for the parameters given to that command. I am sad. I'm going to check something. I am not sure which voice I'm using anymore. This was the voice of the evil guy. But it sounds like I'm just sort of, no, it's because I have been overtaken by the evil guy, which is why I now sound like it. Because of the stupid way this works, I need to check. I mean, seriously. I don't know. I'll need to check before and after. And yeah. I should also do an F flush standard out. Oh, he'll be back eventually. Invalid operation, but the key point here is that this invalid operation only happens in between. You see, if I put triangles, it's not accepting the triangle's adjacency. So I'm clearly doing something wrong. It's not going to tell me what. You see, there are no errors generated here. But if I actually try and use GL triangles, adjacency, then it doesn't draw cos. In fact, there's an error. And the error is error 502, which, you know, is very informative. Given when the set of states for a command is not legal for the parameters given that command. It is also given for commands where combinations of parameter. It's also given for commands where combinations of parameters define what the legal parameters are. Well, in other words, it's saying you did something wrong. Catching errors the hard way. Is there an easy way? Okay, I could try this, but you know, I feel like I'm falling for a trap here because I'm quite sure that what I'm going to do is put all this in and try their little code snippet out. But in the end, it's going to just print the same information, give me the same information I already found. Could be inevitable, yeah, we'll try it out. It's all just wonderful, really, isn't it? It just makes it all sound so great. So here's the first problem, a linker error. No, a segmentation fault. Oh, that's hilarious. There's a segmentation fault. Oh, 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 God. Why? So I'm going to do. Yes, yes. You couldn't make this up. There's still segmentation fault, even without printing. Why? Because I called the message callback. There it was. I said, call me back. Well, that's enough for it to crash. Well, let's compare that little story, shall we? Compare that little story with the marketing spiel. The debug output feature provides a simple method for your application to be notified via an application-defined message callback function when an OpenGL error or other interesting event occurs within the driver. Simply enable debug output, register a callback, and wait for it to be called with a debug type error message. This method avoids the need to sprinkle expensive and code-obfuscating GL get error calls around your application to catch and localize the causes of OpenGL errors, and the need to conditionally compile them into debug builds and avoid the performance hit in optimized builds. The feature can even ensure that message callback functions are invoked in the same thread and within the very same call stack as the GL call that triggered the GL error or performance warning. A simple example showing how to utilize debug message callbacks, which crashes. They missed that one. They missed that bit off. Only reason I think it goes wrong, I've got a theory, I'm piecing it together, I'm thinking, what on earth could it be? And then it hit me. Maybe it's because I'm using both systems. Well, I mean, it doesn't give me permission to use both at the same time, does it? What's going on? Reference to no, it's a segmentation fault. Shall I just add that in? I could edit it. No, I need to log in. I could edit it and add which crashes. You see, it was so idyllic sounding. It was such a great idea. You knew, didn't you know? I did say, and it's not because I've tried it before, it's just bitter experience, that it was probably not going to work as advertised, that it was probably not worth my effort, not worth me even trying. And look, who was right? Yes, I was. Again. What does it not like about it? GL triangles adjacency. What's the reason? I'm going to draw elements. The draw elements. Why? It worked without adjacency. It worked. It needs to be a power of. It needs to be 6. The Kestrel, where are you here? You probably need, maybe I just messed up and I didn't provide 6 vertices. I can't imagine that. Nope. Doesn't work. Error 502. Okay, so I've got a little more information. Error 502, OpenGL. How many different things have I got in there? I'm not doing it in the bind, you see. It's literally only one command that's being executed, which is, okay, GL draw elements. GL draw elements error with 4 exclamation marks. Well, you know, I really don't like excessive exclamation marks. I think they are tacky. I think they are ugly. But there are certain times when they are perhaps justified. And this is one of them. So I forgive the 4 exclamation. Why is your index array smaller than your vertex array? Oh gosh, just a bunch of people guessing. What can cause GL draw arrays? No, it's draw elements. I didn't say draw arrays, I said draw elements. Let me, I don't know. Let me try not binding the GL element array buffer. No, that didn't help. Let's try not binding the vertex array buffer. No. Let's try swapping these two. No. Let's try triangles. Yes. Let's try triangles adjacency. It fails. Error 502. What am I missing? And nobody, I'm the only person in the world who seems to be having this problem. Good night, Refly. Thanks for tuning in. There's nothing to watch except me get frustrated. And frustrating, probably. Object not found. That's a shame because it looked like I found something that OpenGL Super Bible. Look at this. It's like it's incredibly frustrating as an author to spot it. Okay, I can use this. Creative Commons attribution, non-commercial, so up there imported. So, copyright this guy, Joey DeVries. Since it's a book. I'm going to have to try finding. That's it. And he has a whole book on OpenGL, and the word GL triangles adjacency only appears once in the entire book. Well, there we go. Maybe they're not supported. Oh my God! Nobody deal. It must be the only person in the world trying to get triangles and adjacency to actually do something. Right now. Oh God, that means I have to interact with people. Oh my God, I can't. Like, I can't. And go there and say, I'm trying, the first thing people immediately assume you're stupid, or that the question doesn't need to be asked, or that you don't need to do it. And there's got to be one guy there who's like, the culture police of the thing. Who's going to do that? So, yeah, why would you want to do that? And so then I did explain why, or if I'm wise, not. Well, you see, I'm trying to do this thing with a quad. And it was like, well, quads are obsolete. Why do you expect quads? Well, no, absolutely, no, you don't understand. There's something you can't actually do. It's impossible. There's no reason why. I've been through this. I know how this ends. As soon as you start trying to convince somebody, but you see, I don't get why. You remember I was on here and I looked at these lovely errors: invalid enum, invalid value, invalid operation. Where were those errors? Maybe that. Oh. Oh, yeah, these are. That is exactly what they say. It's like invalid operation, invalid value, invalid value. The set of state is not legal. There's something I have to do to make. All right, can I have an example of? Oh God, I'm going stuck in a flipping loop. I want an example. Example of actually using. No, you see, you get this, but they mention it, but they don't actually give an example with it. Here's 1, 2, 3, 4, 5, 6. Oh, here's something. Yeah. Lines with adjacency. Line strip with adjacency. Triangles with adjacency. 0, 0, 1, 2, 3, 4, 5. 6 vertices are given, where n is the number of triangles to draw. 0, 2, 4 define the triangle. Oh, I think I got it. Oh. Double face palm. It's because the shader, the layout in the shader. For what? This is for geometry shader, layout, triangles in. It's probably this. The geometry shader wasn't set to the right layout, so it couldn't accept all the other ones are extensions need to be enabled, probably. So I think this will probably still fail. No. Oh. Ah. you know, the Klingon death ritual. That's a kind of much sort of less intense one for the stupid mistake.
Have you seen bugs? Look.
So the problem was I didn't have the geometry shader configured to accept them. Well, what I've got is I now have a spinning. This is done using the. Oh God, it's late. I'm so close. But I'm always saying that, right? Let me just confirm. Draw is drawing right now with triangles adjacency. It wasn't working at triangles adjacency, now it is. So yeah, it's looking promising. This should draw a triangle, the first triangle of my cube. You remember the cube? Oh, shoot. Something appeared on the screen. So that error that I was getting was due to the geometry shader not being configured to accept the triangle adjacency thingies. Now, I get this guy, 1, yes, it's my first GL adjacency. Do I get a kind of, do I get a trophy? Do I get an achievement? Do I get some kind of prize? Are we gamifying this? I think I need to look at. This is the bit that reminded me of that. Looking at that example there. Here we start with right, made with triangle adjacency. Made insane with triangle adjacency. 0, 1, 0, 2, 0. Nope, doesn't appear. 7, 7, and 7. Come on, it should. The adjacent. Okay, so I think there's a problem that the. Oh, there's a bug. Jeez, it just never ends. If this adjacent thing, there isn't an adjacent. So I just duplicated one. But this made it a degenerate adjacent, and it doesn't render. See? Because it's the alternate ones, 0, 1, 2, 3, 4. So 1, 0, 1, 2 is my first triangle here. which actually looks wrong anyway, because it's like this should be front, top, left, front, top, right, front, bottom, left. So it should actually be vertical. This is so insane. I think the information is wrong. I think that is not right. The first, I think it starts off with the adjacent. So it would be 0. So I say 7, 0, 7, 1, 7, 2. No. Oh, this is so frustrating. Then 0, 7, 1, 7, 1, 6. Maybe to make it different, 2, 5. You see, that's not a vertical thing. That's not going between 0, 1, 2. Oh. See, what I do with the 7 shouldn't matter. It does. Maybe it's something else. Maybe it's 0, 0, 1, 2, 7, 7, 7. But that doesn't match the documentation I'm seeing. Oh. That's insane. That's not the same. So this documentation is out of date. All right, well, gee, there's no end to this. So what have we got? If I'm right, then to build the first side, it's 0, 1, 2, 7, 7, 7, 1, 3, 2. Nearly. Hang on, I said 1, 3, 2, not 0, 3, 2. Let's try that again. I mean, how crazy is that? That's definitely not the order that was being specified. Not by a long shot. Well, can I do the adjacency then for this? No. No, come on, this is crazy. completely different from. Okay, so they must have changed the standard at some point, and everybody's documentation hasn't kept up because, you know. Whatever. So which is it then for the first, second, or third? Well, logically, this would be the one. The first one, 0, 1. I imagine it would be the second one of here should point to 3, and for 1, 3, 2, it would be the third one that should point to 0. So if I'm right, that would do it. The colour of the vertices. Did I set that up? Colours. These have to be different now, but I only need 8 now. Zero is red, 1 is green, 2 is yellow, 3 is blue. 5 is yellow. 6 is green. And 7 is red. Problem is I don't see 2 blues. If 3 was blue, 4 should be blue. That's because I've got one missing. Oh, 1, 2, 3, 4, 5, 6, 7. Those are the colours of my vertices. Okay, now if I go and use the colour of the vertices by going into the deal, we should see here that the colour goes into colour, that goes through into the geometry shader that can take, and what I need to do is, and this goes through to the fragment shader, which is going to the 4 colors, geo color 1, but I just make it color. So if I do this, I might get color of some kind. Yeah, fuck, it didn't work. Color, because I didn't do the VS out color. God, so much to track here. Oh, you bastard. It's that bug where Emacs has a habit of locking up. It's annoying. Shaders. Default dot. There we go. C mode. Now, what we can do is go into here again. Actually, I just had this last thought, which was that's the actually save that. So there, see if this works. Oh, wow! Wow, I might actually get there. So I have some colour. It's still not doing the shading the way I want it, but I've got some colour. Now, to get the shading the way I want it, 0, 1, 2. Close is close. I'm getting there. I think one of the issues I have is that I need to construct. I realise this, that I need to know which of the vertices is the one which is on the opposite side. This actually means I need to redo the ordering. I just realised, because how otherwise is it going to know? But it shouldn't be too hard, as long as I use this version of the numbering, right? 0, 1, 2. I'm going to have to make the first one after. So if that's the case, it means that we begin with the side facing with the edge that is shared between the two sides. If I do that, then I should be good. That becomes 1 to 2 to 0, where this one is 3, and then they can all be 3 to that one. I can just repeat it. That will be the theory. The next one would be, again, start with the shared side, 2, going clockwise, 2, 1, I think, or whatever. I'll sort that out later. But anyway, 2, 1, 3. It's rendering double-sided right now. 2, 1, 3, 0, 0, 0. And you can see what happens with that. Okay. Now, if I'm right with my theory, all of this, I should be able to access the fourth colour. And it should go something like this. Colour 1 equals, just in colour 2, like that. Because there are 6 vertices now, and 3 finally, then I get the adjacent vertex, which gives me the fourth colour in my quad. In theory, I could do the same thing here. 1, 2, 3. These have been numbered from 1, so it's all a bit confusing, but I've got to stick with it for a minute. This is for the second vertex. And then here we have the third vertex. And the 3 vertices each receive the 4 colours through the geometry shader doing its thing. And then finally the rest does its trick. Oh, if I'm really lucky, it'll be, come on. Oh God, that was close. But I can see the line. Why? What happened? Something is. I screwed up the colours because I changed the order of the what? Oh. Oh, that's so tantalizing. I swear it's almost working. It's just some silly mistake. Okay, one way I can try and debug this is by changing the color of the vertices. So if I make one of the vertices black, I'm making 0, vertex 0 black, come on, you can see what happened down there. Weird stuff is what happened. Oh, so close. It feels like I've just got a bug. Emit vertex, emit vertex, emit vertex. I'm curious if because there's this confusion about the order of the vertices. I'm making all 4 vertices black. Okay, so that worked fine. Then I say, let me have the vertex 0 as color red. Right, so we'll study this for a little bit. It's getting really confusing, so what I'm going to do is go, yeah, I'm in main now. Stop the rotation. Oh, because the time starts off at 0. Oh, try again. Okay, so hopefully let's face onto the camera now. And let's bring the camera height down. So we're looking at it face on a little more. So I think it's cutting the near plane. Something's wrong with that. Let's put it down to, okay, better. What do we see? Now the first one is that it's the wrong vertex. It's 0, vertex 0 corresponds, let me move the vertices down. So close. So, minus, yeah, this should be the top left. I can prove that should be the top left if I go and move that top left vertex back, say, half a unit. There's the proof that this is the vertex that I think it is. And so right there, we need to fix the order of the indices. Come on. 1. Yeah, because I've changed the order of the colours. I did change the order of the colours. Oh wait, no. What am I talking about? It doesn't matter. I might start with 1, but these are tied to this. Aren't they? Why are the colours? All right, well, I'm going to have to colour code my vertices. Red, green, yellow, blue, magenta, cyan, no, red, this one's black, red, green, yellow, blue, magenta, cyan, white. And we can see exactly what's what. Right. Black is at the bottom here. I guess the colours are not tied to the vertices, but are tied to the indices, I suppose. It must be. I can't see how else that would go this way. In that case, the third colour, which was green, oh dear. 2. It said 1, 2, 0. Black is in the wrong place. Well, okay. First thing I'm going to do here is get rid of. Next thing I'm going to do is get rid of that second triangle. So I'm looking at the first triangle. Right, so that's geometric, positioned in the right place. It's also 0, 1, 2. I can see that. 0 is the black one, the red one is 1, and the green one is 2. But it's not in the order I would have expected. So what I'm going to try is just put in here 0, 1, 2 and see what happens. 0, 1, 2. That doesn't work as expected either. All right, well, how do I get the right order? Does it matter what I do over there? Not really. Well, it is affecting the blending to the corner, to the one that we can't see, which is proof that it's working, but I've got to get my order right. And the colour is on the indices, which is kind of weird because it's not. Wait a minute, that is correct. Because I changed the order to black. That's right. Okay. No, that's correct. Okay, so then the second, if I say 0, 1, 2, The problem is it doesn't matter what order they are, which one it is. It doesn't, I can put anything I like in here. It only affects it if I'm doing, so if it's important for a tessellator, but I don't care. So yeah. So I can just make it nice and simple. 0, 1, 2, 1, 3, 2. 1, 3, 2. Who cares about the second bit? Not important just yet. What did I get? So 1. So I said 1, 3, 2. So I started with this one. And that came out as yellow. Yellow is 3. It doesn't make sense. Let's do the same again. 0, 1, 2. I've just got to get the right pattern. Well, at 0, 1, 2, I'm drawing the same triangle on there again, right? So instead of 2, I can say 3. 0, 1, 3. Okay, geometrically it is correct. One can say 2, 1, 3. Oh, I'm forgetting. I've got to write out the colours according to. So this actually has 12 colours in it. So I've got to make 12 colours each. No, that's not true. Six, not 12. I have to do 6 colours for those two. I'll just start again. The first colour is 0. That is, I make it red. 1, 0, 0, 1. I think we're getting there. Right. The second one is 1, which is green. 0, 1, 0, 1. The third one is 2, which is yellow. 1, 1, 0, 1. The third one is blue. 0, 0, 1, 1. No. Start again. You got confused. 0, 1, 2, but then I need to put 2, and 2 is yellow. So we put yellow again. And then we have 1, and 1 is green. That's it. And then we have 3, and 3 is blue. And in theory, this should be enough to do the quad. Oh, so close. I didn't get the blue. What did I do wrong? Oh, because the adjacent vertices have to have some colour in them. In fact, it doesn't even matter what those vertices are then. I only need to specify the colour, which is kind of interesting. Okay, start again. The first one was 0, 1, 2, 3, 3, 3, which was red, green, yellow, blue, blue, blue. Blue, blue, blue. The second one is 2, 1, 3, 0, 0, 0. Okay, so that's yellow, green, blue, red, red, red. Maybe this time. Oh. Right, the top one is correct. The bottom one is the wrong order for some reason. Bottom one started off with 2s, blue. It's out of sequence. I said begin with yellow, but I don't see any yellow. Oh. That's really frustrating. This the second triangle does 2, 1. Yeah, well, I'm really close. That's the thing. It's as closest I've been. It's really, really close. A couple more minutes. And then, yeah, I'm going to carry on. So it's just frustrating to be so close and then have to go to bed. But I'm going to have to go to bed. This is like yellow. Those reds never appeared again. Weird. You see, that is not doing anything. It's not changed anything. I think that maybe I'm wrong, and it actually doesn't change anything. Oh, blue. Blue is on the wrong side. It has to do with the order. I did 2, 2, 1, 3. I said 2, 1, 3. 2, which is a theory starting with the yellow. Okay, well, if I try the other approach, which was what was documented, it becomes this. Without trying to, it must have been confusing. I have to believe in the documentation. Not 1, 2, no. Yeah. That's where I'm going. But that was a good run. So close, so very close. Well, I'm off. I have work tomorrow. Thanks for watching. I'll be back again soon. Take care, everyone. Good night.